Digitization of mechanical meter bill generation using OCR. Abstract. Several technologies have been innovated over the years in attempts to digitize every possible process. However, it is much easier to create new technology than to replace the existing ones. There are yet a large number of rural areas where digital meters have not been installed and traditional mechanical meters are still in use. The utility providers have human dependencies to take regular scans of the meters, in person, to generate the bill. To create a hassle-free and accurate billing system, we have come up with the idea of digitization of mechanical meter reading using OCR. Keeping the underprivileged areas of the world in mind, this solution has been developed. Unlike the advanced metering infrastructure, AMI, this method does not require any advanced complex infrastructure. A camera fixed in front of the mechanical meter takes the image of the meter every month and sends it over to the database. Using the image, the current reading is extracted, by OCR methods. Current reading is subtracted from the previous month's reading and stored back in the database. Based on the obtained monthly reading, tariff calculations are made. For the customer to view the generated bill, they will be required to log in into the web application. Keywords: mechanical meter digitization, electricity bill generation, character recognition, OCR. Introduction. Government organizations have been employing people since early times to collect meter reading from each house. This process is clearly inefficient, time-consuming and inaccurate. The chances of human inaccuracy are high. Misreading of numbers is one of the common mistakes happening across. In some houses, the meters are not placed in easily accessible locations. With the increase in population, the number of houses is also increasing. Hence the organizations are forced to employ an excess number of middlemen for this purpose. Therefore, this traditional method can be concluded as erroneous and expensive. To overcome the mentioned disadvantages and discrepancies, technologies like OCR can be made use of. Digitization of analog meter reading implements the modern application of the OCR technology. Optical character recognition, OCR, is the new emerging technology in the modern-day innovation. It is well known for the process of recognizing text from typed content, printed documents, and texts. It has its various applications in the world of image processing. 1. Tesseract libraries help in achieving a precision of 0.929. OpenCV renders the required technology for image processing. The proposed approach for designing this system involves storing details in an admin database, monthly capturing the images, processing of the image and tariff calculations. 2. Ease of use. A service provider's perspective. The current methodology seeks for human intervention for meter reading collection. This method comes with its own disadvantages. Cost inefficiency. Service providers have to ensure that it employs a sufficient number of people for meter reading collection. The addition of extra workforce for this purpose increases the costing of the company. Inaccuracy. Erroneous reading by humans leads to misleading information and results in incorrect bill amounts too. As an addition to the advantages, new users are added into the database by the administration. Access to the database will remain restricted to admins only to avoid trespassing or data theft. B. Customer's perspective. The existing system involves human discrepancies leading to faulty bill amounts. Process of accessing monthly is made very user-friendly. The customer has to just enter his/her user ID to access the monthly bill. 3. Working. Fig. 2. Bill generation process using OCR. A. Image capturing. The new ideology of digitizing analog meters makes use of a camera that will be fixed facing the meter boards. Using a counter module, the camera will capture the image of the meter board on the commencement of a new month. This image captured is sent to the database and stored in the respective tuple. B. Image processing. A. Image cleaning. Tesseract is the best OCR engine with an average accuracy rate of 98%. Image processing is next to impossible without OpenCV. However, to get the right readings from a raw image, some pre-processing and cleaning is required. First, the image is converted into grayscale and then into binary. The purpose of this is, Grayscale simplifies calculations as the picture is only composed of shades of gray. Conversion to binary further reduces complexity. Since any pixel in the image can be either black or white, the pixel can be represented with less information. It also highlights the characters to be recognized, which is the region of interest. The binary image is then resized to a standard dimension using intercubic interpolation 3/4. A sharpening filter that makes use of a 3D NumPy array is applied to the image to reduce blurriness. The filter enhances the contrast between each pixel and its neighbors, thus sharpening the image. Then, erosion and dilation filters are applied. Here, two 2D NumPy arrays of all ones, where each one represents a pixel under the array, and whose number of rows and columns can vary depending on the type of image, are used. Erosion thins down the boundaries, whereas the dilation thickens it. This step ends the pre-processing stage, and the processed image is passed to the ptesseract image _to string function that recognizes the characters and returns it as a string. B. Post-processing, the meter reading is composed of only digits. There could still be some errors such as misidentification while reading the characters. For example, 1 is read as L or I, 2 is read as Z, 8 is read as B, etc. Basic for loop and if conditions can be used to iterate through the string and fix these kinds of errors and make sure that no alphabets were recognized. Then, the string having only numeric characters is then converted to float and used to calculate the electricity bill. See database management. Access to the database is restricted to the administration. Every new user is entered into the records by the admin. This ensures that the data is not mishandled. User details and other required information are stored in the database using SQLite. The database has the following fields: user ID, image of the meter reading, previous month's reading, current month's reading, units consumed this month and the bill amount for the month. After the current month's processing is completed, the database is updated for the next month's process. The current month's reading becomes the previous month's reading for next month and so on. D. Tariff calculations. The resulting output from the character recognition provides us with the cumulative total of units consumed. The total units consumed is obtained after subtracting it from the previous month's reading. Units consumed for the month is used to calculate the bill according to the slab designed by the service provider. E-user interface. Flask framework will be used along with Python backend to create a web application via which the user can log in and view their generated bill amount every month. For results. From the first result Fig 3 we observe that it works with perfection and accuracy for even digits detected after the decimal point. Fig 3, C, is the resultant image after cropping, grayscale conversion, binary conversion, erosion and dilation processing. The database retrieves the data on the basis of the user ID entered. The data extracted helps in the bill calculation. Bill amount is generated using the tariff slabs. V. Conclusion. The above-mentioned approach clearly replaces the conventional manual method for energy consumption calculations. Usage of OCR minimizes the manual data entry work, thereby resulting in better accuracy. By implementation of such an automated method, unscrupulous functions by customers can be avoided. The technique helps in cutting down revenue losses for the government/any service provider. In future, blurred images are sought to be taken care of using newer technologies. Acknowledgement. We would like to extend our gratitude to Ms. Ruby Dinakar, Professor, Pease University, for the guidance provided during the development of this project.